Hey guys, welcome to our lecture on the Calgary Collegiate Programming Contest. I just wanted to say thanks to you guys for those who participated. We had a pretty good turnout considering it's an online event. So I'm pretty happy about that. And so this lecture is just going to be a, comprehensive solution on my problem, and then I'll also get Luke to talk about his problem, predicting GME. And so this problem, Illuminati Spotti, it wasn't in the Division 1 because we thought it would be a little too easy. So we kept it for Division 2. But after going through the submissions and, the things in Division 2, noticed that some people struggle with this, so I wanted to go over a solution. And so for those of you who, basically kind of know how this problem works, I wanted to go over a solution that you might not have thought of as it's efficient. All right, so to start it off, basically, we just have this guy and he's talking about undirected flights. And he's just trying to find this triangle shape within these flights between cities. So, all you have to do, if you haven't thought about it yet, we're going to be trying to deal with undirected graphs. And so we're going to be trying to find triangles inside of these graphs. All right, so the first input consists of n plus 1 lines, and it's going to be basically be the number of cities that you're given. The next are just a city I and the undirected flight that connects another city to J. Each line has n numbers, each number representing a city J in ascending order. Each number can either be a 1 or a 0, where a 1 is a flight towards a city exists, while a 0 meaning that the flight doesn't exist. And the output is just how many triangles there are that are only made by 3 connecting cities, so we can't have like a giant triangle made by, you know, 5 cities or something. And we want to output the number of triangles in the map without repeats. So that means that like triangle A, B, and C is the same thing as a triangle B, C, A. And I give you some sample inputs here. All right, so let's take a look at the solution. So this is the solution that I created, and it's a pretty interesting one. So the first thing that you might notice right here is that I say bits. Uh, if you guys don't know what bits are, well, let me introduce you. It's not something very common, but it's a pretty cool thing. So um, basically, you could think of bits as a boolean. So what we're going to be trying to do is we're going to be making a 2D array of bits, which is the same as a 2D array of booleans. You might ask like, okay, what's the difference between booleans and bits then? Basically, booleans have a size of 8 bits or 1 byte. And so that means that it's going to have more memory and it's going to take a longer time to recover and compare. And it's going to take a lot longer to iterate through compared to bits. And since competitive programming is, dependent on how quick your runtime is, you want it to be as small as possible. So we're going to be trying to use bits today. And so bits can either have a value of 0 and 1, while booleans usually have a value of true or false, which is another difference. So we're just going to be creating, oh, oops, I didn't mean to comment that out, but we're just going to be using B as a bit set for 500. So since the maximum size of cities is 500, then we can just do that over there. And then we're going to be creating a vector, which is just going to be the same as creating a 2D array of bits. So input is pretty simple. All we have to do is just throw this in here. And since we create a bit set, all of the values are automatically set to 0. So we don't have to set them to 0. So we can reduce runtime by saying if x is equal to 1, then all we had to do is just flip this. So this is equivalent to saying a at I comma j is equal to 1 because we're flipping this 0 into a 1. And so here comes the solution. Before I touch on the solution, I want to talk about what we want to think about what we can do to decrease the runtime to make sure that we go through the least amount of iterations of this code. So this first line over here, I equals j, is the first way we can get rid of, you know, iterating through this 2D array for a longer period of time. And so if you take a look at this graph that I created here, say we have the triangles, well, these are the triangles that we have, ABC, ACD, and ABD. And so if we try and graph this out, this is what we would get right here. And so all we have to do, the first thing you might notice over here is that this diagonal is always going to be 0 because it's an undirected graph. So since it's always going to be 0, then that means that we can just skip it. So if I is equal to j, then let's just continue. Let's basically just skip this for loop and let's go to the next iteration. All right, so if I comma j is equal to 1, all we have to do is just go into this statement. So this means that if an edge between I and j exists, then let's go in. So for each of these that contains a 1, we're going to go into them, and this if statement is going to be triggered. This is where things get a little complicated, but how we can basically just take advantage of bit sets over here. So what this does is that this is going to choose individual arrays. This is going to choose one row I, and this is going to choose row j. And we're going to find the and of it. And so I have an example down here, but once we find the and of it, which is just like 0, 1, 1, 1, and stuff like that, then we want to add all of the sum of the and together and add it to our answer. So I'll go over an example. So say our I is equal to 0 and our j is equal to 3. Then that basically just means that our I is equal to a and our j is equal to d. So if we try and go through our array, I and d, that would be located, well, a and d, sorry, that would be located right here, and that's equal to 1. So we know it's equal to 1, then we're going to go into the if statement, and we're going to use this. So what this asks for, as I said before, is that it's going to choose the specific row for each of the for both I and j. So both A and D are called. So we're going to take these rows and we're going to put them over here. Now what the AND does is it's just binary. So you just look at the top one and the bottom one, and you kind of just see if they connect or not. If they are both true, then you bring it down one. And so what this is trying to do is that the first statement basically just means that we've detected an edge that we've found. So we've detected that A and D have a connecting edge. Now all we have to do is just add the connecting edges. If they share uh, flight paths with another city, then we know that's equal to a triangle. And so that's what this does here. So A also has a flight path to C, and D also has the flight path to C. So that means that they're gonna, create this triangle over here. And so we just create the and then this count function just adds the entire row together, and we get 2. So this is an extremely fast way of doing this kind of solution. And since we're dealing with bit sets, that means that we can use this AND function and we can use this count function to add it all up together. And so the last line I have over here is we're just going to output the answer once we go through all the iterations, but we have to make sure that we divide it by 6. I believe some inputs didn't divide it by 6, and the reason why is because we don't want unique triangles. Sorry. Is that true? Yeah, we don't want unique triangles. We don't want any repeats. What this program is going to do is it's going to treat like a triangle ADC as the same thing as a triangle DCA, and that's not what we want. So we had to divide the answer by 6, and we are finished. This is a pretty simple problem, and there's actually a ton of solutions that you could go through for this, but I found this one to be one of the more relatively fast solutions. And yeah, I hope you guys enjoyed. I believe I'll hand it off to Luke for the next problem.
Hey guys, my name is Luke, and I'm back this week to explain a solution to a question that was on CCPC 2021, and that is predicting GME. So this is the question I published for the contest, and I'm going to be going in depth to see how the solution is structured and what sort of approach that I took in order to solve this question. So the key point that I found for this question was that I needed to identify all the actions that a user can take on a certain day. So they're outlined here. So number 1 is the user could have a stock and then sell on this certain day. The user could have a stock and do nothing on this day. The user doesn't have a stock but buys on this day, and the user doesn't have a stock but does nothing on this day. So these are the possible actions that a user can take, and you need to realize that these actions are very, very reliant on the actions that have been done on the previous day. So this is due to the restrictions that were introduced in the problem details. So for example, a cooldown, where if a person wants to buy, so doesn't have a stock and buy, this means that on the previous day they couldn't have sold the stock because in the problem description it specifically said that when a user sells, they cannot buy on the next day. So keeping in mind of these sort of restrictions, if we look at the sort of actions that are going to be done on a certain day. So on day I, if we perform action 1, that means on the previous day we could have only done action 2 or 3. So let's take a look. So if we have a stock and want to sell, this means that we either had a stock and did nothing on the previous day, or didn't have a stock and bought on the previous day. And number 1 and number 4 don't make sense for the previous day. So now for number 2, if we have a stock and want to do nothing on this day, this also means that on the previous day we would have had a stock and did nothing, or we didn't have a stock and bought on the previous day. That's the only way we could have a stock on day I. So now we go to number 3. So number 3 being we don't have a stock but we want to buy. So what's going to happen is if we don't have a stock and want to buy, that means the only option that we have is we didn't have a stock and did nothing. Because you might think that number 1 would be 1, but because of the restriction that I said with the cooldown, where if a user sells on the previous day, they cannot buy on the next day, number 1 is completely out of the picture if the user wants to buy on this day. Lastly, if the user wants to take action 4, which is they don't have a stock and want to do nothing, they either had a stock and sold it the previous day, or they didn't have a stock and did nothing on the previous day as well. So these are the key points that you need to keep in mind while we go through our solution. So now keeping these things in mind, what we're trying to do is maximize our total profit. But the thing is, we don't know what action to take on a certain day in order to get the total maximum profit. So what I'm proposing is you basically just try all 4 actions on every day and keep track of all those things. So now I'm going to be going over the example that I have here. So this is one of the test cases that I had previously. So I'm just going to quickly move over the things I've outlined here so we can reference them as we go through this solution. I'm going to make it smaller. Okay, perfect. Just going to erase the highlighting to make it less confusing. All right, so let's go through. So one thing to note is on day 0, you need to realize that we can't have a stock on a previous day because there is no day -1. It doesn't exist. So we're denoting this by negative infinity. And I'm going to be going more into this later. You might be thinking it could be 0, but it definitely could not be. So and then if the user had no stock and wanted to buy, so this is day 0. So this would cost $1. So their total bank account would say a balance of -$1. Now, if the user didn't have a stock and wants to do nothing, so their bank account balance would remain 0. So now we move on to day 1. So on day 1, let's say we have a stock from a previous day and we want to sell. This means that either we had a stock and did nothing, or we had no stock but bought it. So remember, because on day 0 you can't have a stock from a previous day, so this is completely out of the picture. That's why we're denoting this as negative infinity. Imagine if this was 0 and we took the maximum between -2 and option 2 and option 3. That would give us our maximum of 0 when we want our maximum to be -1. So having the maximum of -1 when we compare the actions 2 and 3, then we want to sell on day 1, so that would get us $2. So then our net profit would be equal to $1, as you can see here, because we bought the stock for we bought the stock for $1, so we had a cumulative -$1, and then now we got $2, so now we have a cumulative of $1. So moving on, if we had a stock and want to do nothing on day 1, this means again we had a stock and did nothing on the previous day again, or we had no stock and bought it. So now we take the maximum and then we put -1 in. Okay, now for option 3. So if we had no stock and wanted to buy on day 1, this can only come from having no stock and doing nothing from the previous day because of the cooldown I mentioned earlier. So then it would take this value and then would make the payment of $2 to come up to a total of -$2. So the last option is having no stock and doing nothing. And on the previous day, this could only come from, again, having no stock and doing nothing, or having had a stock and selling. So this would come up to, so you would take the max of 0 and negative infinity, which is obviously 0. So now we move on to day 2. So in day 2, if we had a stock and wanted to sell on day 2, so again, this is day 2 now. We take the maximum between day 2 and day 3, or sorry, not day 2 and day 3, action 2 and action 3 of day 1. So -1 and -2, and then we take the maximum. We find that to be -1, and then we add it by the price of the stock on this day. So that's $0. So -1 plus 0 is -1. So that's how we got -1 here. So again, if we had a stock and wanted to do nothing on day 2, we would take the maximum between having no stock and having buying it on day 1, or having a stock on day 1 and doing nothing with it. So again, that comes out to be -1, and then we input it into the value here. So action 3 for day 2, having no stock and buying. So again, this can only come from having no stock and doing nothing on the previous day. And then we buy the stock for $0, so we have a total of $0. The final one, no stock and doing nothing on day 2. This comes from either having a stock and selling it on the previous day, and then having no stock and doing nothing on the previous day. So I think you kind of get the gist of it now. So this comes out to be 1 because the maximum between 1 and 0. So as we go through, we finally come up to the last day. And we have 2 values that we want to compare, and that is having a stock and selling on this day, and having no stock and doing nothing on this day. If you look at the 2 other ones, having no stock and buying on this day, this would only give us a negative profit essentially. So we wouldn't consider this. And having a stock and doing nothing would also be non-beneficial because you bought a stock but you never sold it, so that money is simply gone. well, it's not really gone, but you haven't really redeemed it. And in our case, we want to find the maximum profit out of all of these days. So we would take the maximum between 4 and 1, and we finally come up to an answer of 4. So that is how that is sort of how I thought about the solution. And now I'm going to be going over the specific code so you guys can see it in code form. So here I have the actual code that was used to judge the submissions in the contest, and here I have the logic that I used to demonstrate the sample input. So here we can see that we outlined day 1 because it has a special case where it can't have a stock, and it can't do either action 1 or action 2. So we make those negative infinity, as you saw earlier. Having no stock in buying, you would simply just take the price at day 0 and make it negative to signify that we're actually paying money in order to get this stock. And having no stock and doing nothing is obviously 0. So now we enter for loop. We store the previous day's results in 01, 02, 03, 04. And then now we update these following variables with the current day's results. So having a stock and selling, you would take the maximum between 02 and 03, and then add the price on the day we're on, signifying that we're basically selling our stock in order to gain back money. Here we have a stock and do nothing, so we simply just take the maximum of 02 and 03. 02 and 03 being having a stock and doing nothing, or not having a stock and buying. So that makes perfect sense. The third one, so having no stock and buying, we simply take option 4 because that's the only option that could come from, or that's the only possible action that could have been taken on the previous day for this option. So we simply take 04 and then we subtract it by the price on our current day, signifying that we're paying money, in order to buy this stock. Lastly, we go and look at having a no stock and doing nothing. So we simply take the maximum of having a stock and selling on the previous day, or not having a stock and doing nothing on the previous day. So that also makes perfect sense. So as this for loop runs through, it's gonna do the computations I showed you manually on the OneNote earlier, and then in the end it would print out the maximum between having no stock and doing nothing, and having a stock and selling on the last day. So that concludes my part of the presentation on my problem. I hope my solution made a bit of sense to you, and if you had any questions about my solution, please let me know in the Discord, and I'll be happy to elaborate more on my logic. And please note that this isn't the only way to actually solve this problem. So there's definitely many other approaches that you can take. Your code might have looked a bit different. Your logic might have looked a bit different, and still passed all the test cases. So good for you. And yeah, so that concludes it. And if you have any questions, please let me know in the Discord, and I'll be happy to help. Thank you very much, and have a good rest of your day.